Second. All right. Well, we're going to kick off here. I know we have a couple folks still streaming in here, but I just wanted to first say how excited we are to have everybody here for this Energy Innovation Summit here with TandemNSI. My name is Michael Hoffman. I'm the Director of Marketing here with Tandem National Security Innovations, and we're excited to be here with AUSA's Great Conference Center. This is the second event we've had here now, and I know how excited our network was to have it here in the first place. But tonight's Energy Innovation Summit, and we have 7 government agencies represented tonight to really give you kind of an inside look at the different technology that's coming out there and different opportunities for small businesses to get involved. So we have a wide swath between the Department of Energy, the Marine Corps, and the Army. So moderating our first panel, which is going to be focused on mobility power in the military, it's going to be Jonathan Aberman, who's the founder and managing director for TandemNSI. So I'm just going to hand it over here to him. But thank you again to AUSA, and I also wanted to say thanks to Arlington County as well, who's been a longtime supporter for us as well. Thank you.
These are on. Can you hear me?
Are they on?
I love technology.
There we go.
All right. Said it was red. Hand it up. It's on. I don't understand this stuff. I mean, not like I do anything like singing a rock band or anything where I would know. I do, and I should know. Anyway, so we're talking about energy tonight. It's a lot of fun. Really glad you're here. I want to thank Arlington County for seeing this program 2 years ago. We all would be here if Arlington hadn't had the vision of providing the seed capital with the Commonwealth to get us going, and we're always going to thank you for that. And I also want to thank Eastern Foundry. You guys know who they are. If you don't, if you're doing a government contracted startup, you're looking for an incubator, highly recommend we work with them a lot. Great panels, and really a hallmark of what we're trying to do here at Tandem, which is make these guys the rock stars. I, for many years, was part of the venture capital industry, and some of you know that. And I'm, having been the subject of many funding events, you know, you realize that VCs do an amazing job of putting themselves in the middle of the ecosystem of startups. The reality is that war of national security not working. So do I have to start from the beginning? You want me to do it again? I'm going to tell you, no, for God's sakes, no. It's bad enough you've spoken too much. That's great. It's like we're old friends already. Anyways, the whole point here is these guys are the rock stars. You're the rock stars. Our job is to get out of the way after we facilitate the conversation. So on the panel we have Brian Kiviat. He is Deputy Director for the Marine Corps Expeditionary Energy Office. And his main, what I've been told by my crack team is he is particularly interested in energy harvesting. He embraces to collect energy, move into marine lakes. Jose Collazo, excellent, is over there as well, and it's 2 for 2 so far, I hope. And he's an energy harvesting engineer with the U.S. Army, and very interested in energy harvesting again, particularly movement of the backpack, and even the friction movement of clothing. Von Cresce, you know, I completely spaced on that, sorry, Von. Von's a material scientist with the Army Research Laboratory. The research lab, I want to point out to you, if you're an entrepreneur, you're looking for resources, an opportunity to partner, the ARL's got an amazing open campus initiative going on where the doors are open. They're looking for entrepreneurs to come and work with them on entrepreneur ideas, use equipment there. It's really great. Von's area of interest, apparently, I've been told, is ion batteries in pursuit of lightning and strengthening batteries. And then Vijay, and that's Acharya. Close enough for rock and roll, or close enough for government work, right? You're an engineer with the Army PO Soldiers Power Team, and you're interested, looks broadly in power distribution, batteries, and harvesting as well. So What we want to do is talk a little bit about this whole challenge of energy. So I have been told, guys, that the average soldier these days carries 17 pounds of batteries for a 72-hour mission. Is that true? Is it that much? And how important is it to help the soldier to cut that weight down?
I'll start.
I know, we're masters of tech, right?
Hello.
There you go.
Hi again, Vijay, Acharya here from the Soldier Power team within PDO Soldier. The sole purpose, our mission, our vision statement is to reduce soldier burden and those energy logistics. And the easy way of doing that, not the easy, the hard way that we're trying to tackle that is to tackle the soldier battery load. So for a 72-hour mission, you know, depending on the mission concept of operations that you're running and everything, they're carrying upwards of that amount of batteries, absolutely, sometimes more, just depending what kind of special mission equipment they may or may not have. So what we're targeting is trying to create safe, more lightweight batteries that the soldiers can carry and wear, most importantly, that don't encumber their movement or their motion. And also a recharging suite of equipment as well to help those batteries be recharged in the field with renewable solutions like the sun we have coming through the windows right now, and also, you know, fossil-based fuel systems as well. So, and the renewable, and the generation tools as well. The CERDEC and other partners are helping us develop.
So what about the batteries? Okay, so I wasn't mistaken. My team's prepared me properly. So I will tell you, I find that mind-boggling. You know, to think that we're sending people off where, before they do anything else, they're carrying around 17 pounds of extra stuff on top of their equipment. What about the energy harvesting? That's to try to lighten the load. You're all working on that, right? Just run down.
So one of the ways that partner Vijay mentioned that we're trying to tackle the burden that the soldier has in regards to batteries is by using the motion that they're already having to use to get from point A to point B. So to use the excess energy that the human body makes and harvest that into, in our case, we're using electromechanical motion or electromechanical generators to turn that motion into energy and recharge a central battery.
So Britt, do you want to come up and join us? You got Britt Kelley is from DITRA. He's also on the panel, and actually we were just up at his offices earlier today, and I can tell you the traffic sucks. And so you did well to get here.
And if I could add to that, I'm Brian Kiviat from the Marine Corps. So we're actually working together with the Army on that project, and one of the things is looking at the backpack. So if any of you have gone hiking with a large pack, every time you take a step, that pack bangs you in the back. So that's a lot of energy. So if you could take that energy and not put it into the Marine's back, you put it into electromechanical and then turn that into battery power, you've killed two birds with one stone. The Marine saves his knees and his ankles, and he's charging up his batteries. So it's, I believe some of the Army folks like it just for just to save the Marine's back, or sorry, the soldier's back. So just from an ergonomic reason, that shock load is being reduced. From a power, you get free power on top of that, so everybody's happy.
Sure thing. Yeah. So from a material science perspective, we're also interested in storing the energy. So for the Army Research Lab, we have projects in grid storage. So this is the kind of thing you'd see supporting small camp microgrids. So as Jose says, you got to generate that energy, but at the end of the day, if you have extra, or if you're generating camp, you'd like to put it someplace that's safe, because electrical generation through fuel is quite expensive. The price of a gallon of fuel, a lot, $400 per gallon, more or less.
Depends where you have
Right, right. So a lot of money. So what we're hoping to do is make a nice, safe place to put the energy if you're generating it by solar, wind, or by other means, but to have a camp battery that's safe, something that won't catch fire, for example. Somewhere where the energy can go and can balance the energy in camps. So along with generation and harvesting is storage. So sort of we're all kind of working together towards the same problem.
So Britt Kelley, who joined us, who fought through traffic from south of here, just so you know where he's coming from, he is the Unmanned Systems Integration Manager for the Defense Threat Reduction Agency, or DITRA, and they're very interested in power sources for unmanned sensors. So,
Yeah, thanks. Sorry for being late. Traffic is awesome as always in DC area here. At DITRA, our main mission is, protecting the U.S. and our allies from the threat of weapons of mass destruction. And so we have a number of ways we do that, but I'm in the R&D section, and in our group we're looking for unattended sensors that we'll put out and we want out there for a long time, which with current battery life is less than optimal. So we're looking for ways to improve that. And then probably like everyone else for unmanned systems, whether it's ground, air, or undersea. We're looking for ways to extend those batteries.
So let's get a little more granular. Vaughn, I believe that it's fair to say lithium ions get a lot of attention. It certainly has got a lot of attention in the private sector, but thanks to Elon Musk and others. But what's your view on the promise of this technology, the risks involved, and how is what's going on in the private sector with things like Tesla and some of the other things going on? How do you see it all bolting together?
Well, it's interesting because Tesla and the other OEM manufacturers, GM, Ford, Honda, you can kind of see two different strategies. You see Tesla, they're going their own way. There's always a mitigation between the risk of the battery, like the amount of energy you carry, and the risk of fire, and then the safety and how much pack you have to put around in order to ensure that safety. So I think lithium-ion batteries still have have at least some room to improve. There's more energy density. I think the modern batteries are maybe 250 watt-hours per kilogram, which is a pretty good number for a battery. But at the same time, like there are other technologies, or there are other lithium technologies that are coming that may raise that even higher. And so, but at the same time, there's a risk mitigation. Like these are batteries, we've all seen the pictures of Teslas burning on their chargers and stuff like that. Or just the risks of an accident, like if the battery pack is bent, what happens? So I think there's a lot of promise, but there's a lot, you cannot ignore the risks. Otherwise, there'll be more and more sort of public failures and lives lost. So that's something we really have to, especially for the soldier, where energy is the primary concern. They have devices that they need to use to accomplish their mission. And there's only, there's enough risk that you can accept. But at some point, if your battery would be overcharged and explode on your person, that's a big problem.
Yeah, I think that's right.
Yeah. I can say, even though I'm not a soldier, I can attest to that.
I can say as a civilian, I don't like it when things blow up.
And let me add to that, so the Marine Corps, the difference that the Marine Corps brings to this is Marines travel on Navy ships. Fire on a ship is a bad thing. So there's a whole nother level of safety that's required to get something qualified to go on a Navy ship. We're looking now at battery standardization. There's hundreds of different types of batteries. And every new kind of battery, it's probably about $1 million to get that cleared safety and get it on a Navy ship. So the question is, are there ways to, we probably can't go from 500 batteries to 5. Can we go from 500 to 300, 500 to 200? Just lower the number, and every different type of battery that you don't have to add on is $1 million less safety testing that needs to be done.
So who and how is it determined what the specifications are for the battery size and composition? Since it sounds to me like you're not running down to CVS and buying AAAs.
Well, it's interesting you said. So one of the things that we're looking at is if we do have a series of sort of cleared battery types, how do you get programs to use them? Mm-hmm. If you're a program manager, you're trying to make sure that your product is it's on time and within budget. I'm not worried about saving him money. So are there ways of explaining to them, okay, if you use a standardized battery from this book here, we get a book of batteries, that saves you $1 million, and it saves you the time required to get that cleared. So, and then also what it gives you is interoperability. If one of your batteries goes bad on a important system, it'd be nice to be able to just take any battery and plug it in, or have a conformal battery that everything plugs into. So you don't say, okay, I've got a round hole and a square plug, and I can't charge because I've got an iPhone and he's got a Samsung, and we have different chargers. If you're in the mountains of Afghanistan, that's not a good thing. So how can you make things more common or conformal? I saw over there somebody's got a power manager. So you can then bring in the need harvesting, the backpack, the solar, who knows what the next kinetic way of getting energy is, and be able to manage that into a single battery, and then just plug all your radios and your night vision devices and your electronic warfare systems and all this new stuff that we're adding without having to add a new battery for every single one. Go ahead.
If I may add to the conversation here, the topic of safety, the conformal battery that was mentioned as well. It's been designed by the Army to be, I was about to say bulletproof, it's not true, so they can take a ballistic round. So we reduce the energy capacity of that battery, but increase the safety margin of that battery. So it's designed to be able to be shot, I think, 3 times and without a kind of catastrophic event within 5 minutes. If you're familiar with the BB2590 series of batteries, you shoot those once, they immediately kind of have a catastrophic reaction. And they don't explode, but they're just a violent fire. With the conformal battery, it's a smoking event, and then the soldier, the Marine, can doff that battery in time and go forward. Onto the requirement, who tells us? So we have a requirements community for the Army down at Fort Benning, the Maneuver Center of Excellence for PDO soldier. So they tell us kind of what they need. They say, okay, you need to make a battery. It's 150 watt hours. It needs to provide this much. It needs to provide that much energy to supply this type of mission set over a certain period of time within this envelope to be conformable and worn on the soldier. So with those parameters, and we derive from those things, those performance specifications that go with our requests for proposal to say, okay, this is what we need. And before those RFPs go out, we have interactions with industry. We'll put out a request for information on the ops to get the feedback from industry on what that should look like. If we're asking for too much, or maybe can you do a little bit more? So there's a lot of stakeholders involved in actually getting that spec out, which is that requirement that to fulfill that requirement that we're asked to.
One of the reasons I'm asking is that I was at another meeting yesterday with another agency, and they were talking about, that they don't actually handle the communications aspect of their mission. So they're saying to innovators, look, if you're going to come in with a communications solution, you're wasting your time. And don't bother. If it bolts into communication, don't try to backdoor me into some communications. Again, what I'm getting at is ultimately there's standardization for battery types. Somebody shouldn't come to you with a new battery frame. But so where is the cutting edge right now? And I do want to start talking about harvesting too. But let's talk about the batteries. But where is the bleeding edge right now? Is it in the government? Is it in the government labs? Is it private sector? Where is it, and where is it going? I assume we don't have the arc reactor yet, because if we did, Tony Stark would have told us already.
Yeah,
we'd be done, exactly. The Iron Man suit would work and tell us it was
This
done.
room's not clear for that.
No, it's not.
Before I pass Mike, at the PM, we're not looking at that cutting edge. We're aware of it, but the guys at ARL and at CERDEC and those other labs and our equivalent on the Navy and the Air Force side as well, and perhaps the energy labs as well, they're looking at those things on that cutting edge of the chemistry. One last point on the conformal battery, you mentioned centralized charging and different battery types. This centralized charging solution is pretty significant for the Army. Central power solution. With the distribution hub, a power data distribution hub, with that one conformal battery, that can power, directly power or keep trickle charge the batteries on the devices, on the radios, on the end user device, which is basically a smartphone one on the soldier, or the GPS device as well. So the soldier only has to worry about one battery at the end of his day, at the end of his mission cycle. So he takes that one battery out, he has it fully charged when ready, puts that one on the charger, and he's good to go. He's not worrying about these other battery types. So that's another way that we're trying to tackle all these different battery types out there. So a little aside from before, and also the battery chemistry.
All right, so the bleeding edge, at least if you're talking like automotive, the automotive industry is a good barometer of the bleeding edge because they have to use this stuff in a very public forum. So it boils down to lithium-ion batteries that have a nickel-rich oxide cathode and some kind of either graphite or maybe silicon-enriched anode. So they're the guy, that's the technology, like the bleeding edge is like the stuff we have in the laboratory, which is fun and very small cells. But we have cells that can beat that. But they haven't been as rigorously tested. They're things where we push the voltage of the cell from 4 volts for a typical lithium-ion cell to 5, and things like that. So we can get a lot more energy out, but we have not gone to the lengths to prove that this is something that's really safe or is as long-lasting, because at higher voltages the materials are under a lot of strain. Let's say just a lot of chemical stress. So there's one thing to be on the bleeding edge. There's two bleeding edges. There's the one which works, which you can say is what we use in our cell phones right now, cobalt oxide. What's in cars, which is a nickel-rich, nickel-manganese cobalt oxide. But then there's the laboratory stuff. We've all got our cool formulations that are, like some of them are really hot, and we're using materials that are really good in our eyes because they have very high voltages and very high capacities. But we, for example, we can't guarantee after 1,000 cycles that they'll still be good, because that's a huge barrier to adoption, both by military and by civilian users, is life. So if I have to buy this $5,000 battery pack, and it has great capacity, but then a month later, it's already got less, noticeably less. It's a huge problem for us. So there are two bleeding edges. But what I like is that the automotive industry is sort of taking, and this boils down to the military as well. There are batteries that work. Like we were saying, like there's some trade-off for safety. Like you can have a very safe battery that has a low energy density, and to a certain extent that's acceptable. What we're hoping to do is combine both high energy density with safe operation. But yeah, like it's really interesting to see. If you read like scientific literature, there's a lot of very interesting work out of Stanford, the Army Research Lab. Obviously, we have a great team. CERDEC, these guys testing their batteries for us. We're surrounded by a lot of very good players in this industry, like right up there. But yeah, it's nice to see sort of chemistry is advancing, but there are only so many elements in the periodic table. So we're hoping to find other things. We would like to utilize lithium metal, for example, because even though it's not particularly cheap, that's the most energy dense anode you could possibly have, at least in terms of lithium, in terms of a metal that can be oxidized and produced. So we're really looking for, even though that's what caused, like in the 1990s, all the laptop battery fires, there were Sony Moly batteries that were lithium anodes, and they burn. So yeah, we're looking right where, we had a meeting recently about this. We're looking towards these very high energy chemistries. We know that they're energy dense, we just want to make them so they don't burn, or they said they don't degrade over time. That's a huge concern for us. But yeah, so two different things to say.
So I'm hearing that what I'm hearing is that their technologies that are along the way, they're challenged, but yet there's an insatiable need for power, with the mobile solar, the offset strategy. And then I think to myself, you talk about lithium and the market price. I don't want to, are we in a situation where we're heading towards a perfect storm where our need for battery technologies and for advances in power harvesting, which we'll come to, is going to become of national security importance to, could this become a really big opportunity for entrepreneurs, even bigger than it already is, based upon where things are going?
Absolutely. This is a big issue. Britt mentioned unmanned vehicles. Just about a week ago, the Marine Corps is looking at small UAVs. These are, backpack. So once you talk to the requirements guy, so what's the requirement for it? So it needs to fly for about 30 minutes. I said, okay. How many times a day you can fly? About 6 times a day. Okay, you're going to be out for how many days? So how many batteries are you going to bring? So the thought was, I need a battery that lasts 30 minutes. The reality is I need a battery that lasts 30 minutes 6 times a day for 4 days.
Right.
So that's a new requirement. Marines didn't carry unmanned vehicles 10 years ago. This morning I had a meeting, they were talking about this new communication system. It's this great network radio. What's great about it is it's a network radio, so all the radios are constantly talking to each other. So everybody knows, so if something goes down, it immediately reconfigures. Well, for our radios to always talk to each other, they're always sending out energy. Boom. So that's another battery requirement, and now the vehicle that radio is on, they were running it 17 consecutive days. The engine was on for 17 consecutive days because they didn't have power on the vehicle. So they needed to have the vehicle running to have enough power for the radio. So everything, we're putting all this great stuff on our Marines and our soldiers, but every one of these new devices needs some kind of energy. And they can only carry so much. And as we talked about earlier, you take 5 pounds off the Marines, put 5 pounds of bullets back on. So we're not reducing the load on the Marine. We're just allowing them to carry more bullets. So, or more water. Well, that's another thing that our office is also looking at is water. How do you scavenge water? Water is very difficult, very energy intensive commodity. So if you have to bring it in, that's fuel. It requires fuel to bring it in. If you can scoop and go with some sort of a low energy way to make that water potable, you've now saved energy. So we're trying to look at it as a full system of all the different things, the highest fuel, the most fuel intensive things out there. Water is top.
What about fuel cells? Is there anything there?
We're actually looking at a fuel cell solar UAV. We actually have, it's a joint program, we've got some Department of Defense OSD funding that's got fuel cells, Naval Research Lab, Ion Tiger is what was the original project was called. We combined that with, we've got a solar soaring UAV. So combine the two, so you use the fuel cell at night, solar during the day, and the goal is perpetual motion. We're not there, but it's a pretty exciting next step.
So that leads me to, Jose, we'll start with you. And now we're harvesting, capturing energy. Let's start with kinetics and go from there.
So, like we've mentioned before, the soldier is more technologically advanced. It has more devices, can make more informed decisions. Therefore, the soldier is deadlier. But the other side of that coin is that all these devices need to be powered, and like my colleague previously mentioned, most of them have either different batteries or different ways to power them. And there's different ways to tackle that problem. One of the ways is power management, so have a central battery that can be constantly trickle charging batteries of all the other devices. And another way that the one I more personally work with is energy harvesting. So taking that biomechanical motion and instead of letting it go to waste, some of the motion that the human body already produces, then capturing that and storing it. So in my team, we're currently looking at either backpack motion, so taking a backpack and then suspending the load on the backpack so it lags according to the center of mass of the human, so that you have kind of like a floating bag. So, and that does two things. Well, one, it reduces the reactive forces on the shoulders, and that it therefore makes it more ergonomic. And the other is that you're harvesting the energy. You're actually putting that work into your battery. So that's one of the things. Another things we're looking at is heel strike. Putting some sort of electromechanical generator in the sole of of the soldier's boot to generate power, because you're already, like I said, the soldier may not always wear his or her rucksack, but the soldier is always wearing his or her boot. So we're trying to leverage that. And we're looking at a technology that is easily applicable in other places of the soldier. For example, maybe the generator is better put to use, because if you put something on the boot or on the lower side of the soldier, if you run into a problem, is how are you going to route that to the central battery? How are you going to get that power from point A to point B? So one of the things that we're doing is we're investing in technology that is easily applicable in other places, like maybe the backpack strap. Maybe the forces that pull the pack down, you can leverage that power as well. So we're looking all over the soldiers' kind of repertoire in order to be able to harvest.
And in addition, we're actually the same team, but both Marine Corps and Army's working together on that. The other thing is they've got knee braces that kind of look like, if you've seen football players have to get their ACL ripped. And at the joint, when the knee moves, there you go, you've got a generator. One of the issues with all these things are anything that you put on the legs, every time you move your leg, you now have to lift that up and put it down. So you're now adding work to the Marine or the soldier. So there's a balance there, is how do you maximize the energy out and reduce the weight of the item, so then you're also reducing the amount of work that the Marine or the soldier has to. You don't want to make marching any harder than it already is when they're carrying 110 pounds. So how do you get the energy out without adding any more physical load?
The goal is to yeah. The goal is to make that system efficient enough that when you compare it